All right, we're going to continue on with chi-squared goodness of fit test. So the next thing is talking about the degrees of freedom. In finding the p-value with the calculator, you should have noticed something called df, which is called the degrees of freedom. So if we go back up to this graphing calculator, here is the degrees of freedom for that word problem with the dice. The degree of freedom is 5. So what does the degree of freedom say? In a chi-squared goodness of fit test, the value of the degrees of freedom is the number of values there are that are free to vary. For example, consider the population proportions of 3 categories: p sub 1, p sub 2, and p sub 3. Since the proportions, they must add to 1. We can therefore write any one of those proportion in terms of the other. So for example, p sub 1 equation would equal 1 minus the p sub 2 minus p sub 3. So only 2 of those proportions are free to vary. So here's the equation you must know for chi-squared goodness of fit test. The number of categories there are, and you're going to subtract 1, is how you find the degrees of freedom. So if we go up to this word problem, there were 6 categories. And you would subtract 1 to give you 5. So the degrees of freedom would be 5. And that's where it is on the graphing calculator that we talked about earlier. So here is the steps for the chi-squared goodness of fit test. Step 1 is you identify the null hypothesis on the alternative. Step 2 is you state the significance level. Step 3, you calculate the value of the test statistic with the formula. Step 4, you can use technology to calculate that p-value using the degrees of freedom, number of categories minus 1. And then step 5, reject the null hypothesis if that p-value is less than the significance level. And then you'll need to interpret your decision in context of the problem. Make sure you write your conclusion in a final answer. I did put the steps to our students' t-test. Notice that step 1 and step 2 and step 3 look very similar. So just be aware that there is a lot of similarities between these two tests, between what we're working with today, the chi-squared goodness of fit test, to what we worked on earlier in our course, the students' t-test for population mean. All right, so we're going to go ahead and do example 4 in our book. The table along the side shows the grades received by university students taking a second-year computer science course. So here are the grades and the number of students that got those grades. So in the high distinction category, there were 16 students. In the distinction category, there were 21. In the credit category, there were 21 students. The students that passed the class got a grade of a passing is a 59. And then there was 34 students that got a failing grade, giving you a total of 151 students. So in the following semester, a new coordinator is appointed for the course. The new coordinator is concerned by the high number of high distinctions and distinctions awarded and wants to determine if the course should be adjusted. So it is considered usual if 5% receive high distinction, 10% distinction, 15% credit, 40% pass, and the remaining 30% fail. So what we're going to do is we're going to conduct a chi-squared goodness of fit test to determine whether the course should be adjusted with a 5% significance level. So what we're going to do is I'm just going to erase this here. Identify our probabilities. So the first probability is 5% who received high distinction. The next category was 10%. Then we had 15%. Remember, we're writing those as decimals. And then 40%. And then 30%. So there's those 5 categories. The alternative hypothesis is that at least one of those does not equal 5%, 10%, etc. Step 2 is to identify the significance level. So the significance level as a decimal is 0.05. Step 3, we're going to go ahead and create our chart. So here is that first grade of high distinction. There were 16 students that got a high distinction. So you want to multiply the number of students in the expected, 151 students, and we said there was 5%. So what's expected in that category is that 7.55 students should have received a high distinction. And then what you do is you take the observed, 16, minus the expected, you square it, and then you divide it by the expected. And what you get in that row is 9.4573. Right here. You would do that for the next 4 categories. And then what you're going to add up is this last column to give you your total. So that's your chi-squared calculation. Step 4 is you're now moving on to the calculator. You find your degrees of freedom, the number of categories, 5, subtract 1 and you get 4. So now in list 1 is going to be what you observed. List 2 in your calculator is your expected. And then you would choose the chi-squared goodness of fit test. And there is your p-value. And notice there's your chi-squared value and your degrees of freedom. So when we use our calculator, there is our p-value. So we have to compare our p-value that we got with our calculator. Is it less than 5%? Or is it greater than? So our p-value was 0.00529. Is that less than 5%? Yes. So what we do is we have evidence to reject the null hypothesis in favor of the alternative. So what does that mean? Since we accepted the alternative, we conclude that that course should be adjusted. The grades should be changed.